In this section, we will discuss some of the most important parameters that will be very important in understanding lens specification. The first one is the f number. It is defined as the ratio of the effective focal length and the entrance pupil diameter. This is one of the most important parameters that you will encounter in optical system design. The f number controls a large number of design parameters. Some of them are listed here. It controls the overall light throughput, the depth of field, and the contrast that can be achieved at a certain specified resolution. As you will see in the following slides and the upcoming sections, higher f number will increase the depth of field, but it will also mean lower diffraction limited resolution, light throughput, and the numerical aperture. From the relationship between the aperture size and the f number, we can see that f number scales as 1 over d. It is then trivial to realize that if a lens has a small f number, that would mean it can allow higher light throughput, and these lenses are considered fast. Another parameter that specifies the light gathering capability of a lens is the numerical aperture. It is essentially defined by the marginal ray angle here, and the proper definition is the product of the sine of this angle theta and the refractive index of the medium where the lens resides. At the paraxial approximation, we assume that the angle is small. That's where the word paraxial comes from, because it's close to the axis, per axis. At this approximation, sine theta can be approximated pretty well by theta radians, and the Na is related to the f number by this relationship. Something that you need to keep in mind here, for angles larger than a degree, this paraxial approximation introduces significant error. While Na of a microscope objective is usually specified in the object space, the f number is usually specified in the image space. And another interesting thing to note here is that the diffraction limited spot size that can be achieved by an optical system is limited by the wavelength and the numerical aperture or f number only. Only these two parameters, wavelength and numerical aperture, are equivalently f number, nothing else.